Hello and welcome back. In the previous lesson, we talked about routing, specifically internet gateways, route tables, and subnets. And in this lesson, we're going to talk about VPC security, again, network access control lists and security groups. And hopefully when we're done, we'll have a full understanding of all the components that are needed to serve traffic in and out of the AWS VPC. So first, let's focus on network access control lists. And what we'll do is over here in the console, we'll click on that section here, network access control list, and we can click on it to take a look at what's going on here. So if you remember, as traffic comes in from either AWS users or front-end customers using either HTTP or SSH protocols, the traffic will come in through the open internet into the AWS container through the internet gateway to a route table. And the route table, depending on where the packet says that it needs to go, will route that data to the correct subnet and then to the correct instance. However, it now has to pass through several layers of security before it ends up getting to the particular instance, because we don't want traffic that is unwanted or unverified to come into our VPC and to find our instances and access our data. So first layer is the network access control list. And the network access control list, as you see, sits outside of the subnet. It's inside the internet gateway, but it's outside of the subnets. So let's talk specifically about what network access control lists are. So network access control lists, often referred to as ACLs, operate on the network or subnet level. They support allow and deny rules for traffic traveling into and out of subnets. So that's very important to understand. Just network access control lists allow or deny traffic on the subnet level, so into and out of a subnet. Network access control lists are stateless. I want you to remember this. They are stateless. So that means that return traffic must be allowed through an outbound rule. So what exactly does that mean? That means that if I'm an EC2 instance inside the VPC and I send a request out over HTTP protocol, that means that in order for the reply to come back from that request, there must be an allow rule allowing HTTP protocol to come back into the subnet. On the flip side of that, if I'm sitting outside of the VPC and I send an HTTP request into the subnet and there's an allow rule for that so that the HTTP data can go into the subnet, then the reply from the EC2 instance back outside of the subnet or outside of the VPC, there must also be an allow rule for HTTP protocol in order for that information to leave the subnet. So in order for certain protocols to come in and out of the subnet, there must both be an allow rule for incoming traffic and an allow rule for outgoing traffic. That's what stateless means. So also, they process rules in number order when deciding when to allow traffic. And we're going to go into more of this in detail in a second. Rules are evaluated in order, starting with the lowest rule number. For example, if traffic is denied at a lower rule number and allowed at a higher rule number, the allow rule will be ignored and the traffic will be denied. What does this mean? Let's take a look here at our network access control list at our inbound rules. For the default network access control list, all traffic is allowed both in inbound and outbound by default. Because you see here, for Rule 100, all traffic type, all protocol, port ranges, and sources, it's an allow rule for everything. And if you remember, based on the rules that we just read, starting with the lowest number, that gets evaluated first. So to give you an example of what this could look like, if different rules are set up, we can take a look at this screen capture here. Here we have Rule 80, Rule 90, and then the catch-all, which I'll talk about in a second. But Rule 80 is an SSH over TCP protocol, port 22, and that's an allow rule. Then also Rule 90, being an HTTP rule, is an allow rule over port range 80. So what would happen is if HTTP traffic were to come into the subnet that this network access control list was associated with, it would start to run through these rules. So the traffic comes in, and we know that it's HTTP traffic. The network access control list would first look at this first rule, 80, because that is the lowest rule, right? 80 is lower than 90. So it's going to be evaluated first. And it's going to say, hey, I have HTTP traffic here. Can that traffic come through? And it's going to look at Rule 80 first. Rule 80 is going to say SSH, and it's going to say, no, that's not allowed because Rule 80 did not allow HTTP traffic. Go on to the next one. So it will then go on to the next rule, being 90 here. It will say HTTP traffic. Is that the kind of traffic that we're getting the request for? The network access control list will say, yep, that's it, and it will allow the traffic into the subnet. Now, let's say that we had a different type of traffic coming in. Let's say that we had RDP traffic coming in. What would happen is the RDP traffic would come in, Rule 80 would be evaluated first, and it would say, nope, that's not correct, that's not the right protocol. Same thing for 90, it would take a look and say, nope, RDP is not HTTP. Then it falls to this catch-all rule. So what would then happen is it would deny the RDP traffic from coming into the subnet. So the last rule in every network access control list is a catch-all deny rule. This means that unless a protocol or port is explicitly allowed, it will be denied. So that's important to understand here. For both inbound and outbound rules, protocols must be specifically allowed in order for that traffic to come in and out of the subnet. And if no rules are specifically set for that type of traffic, then it will just be blatantly denied. So another thing to understand is that a network access control list is an optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of one or more subnets. So each network access control list can apply to one subnet or multiple subnets. So again, looking at our diagram here, I have one network access control list that is encompassing two different subnets, both a private and a public subnet. That doesn't matter in this case, but the same rules for traffic that can go into this subnet would apply to traffic that can go into this subnet because the same network access control list is encompassing both. So again, I have another section here on ACL rules because I really want to make sure that you understand what's going on here. So again, rules are evaluated from lowest to highest based on rule number. The first rule found that applies to the traffic type is immediately applied regardless of any rules that come after it, meaning it has a higher rule number. So that's important to understand as well. Going back to our picture here is that if I were now to add a deny rule, say I made rule 100, and that rule 100 was SSH deny rule. What would happen is that as the rules are being evaluated, the first rule would be rule 80. And so if I were to send SSH traffic into this scenario, first would see rule 80, SSH, and it would allow the traffic in because the second that it meets the criteria and it finds the right rule, the right protocol, then it would send the data through, even if 2 rules later, rule 100 was a deny rule for SSH. So again, it's very important that it evaluates it from lowest to highest, and as soon as it finds a rule that applies to that type of data, it will immediately apply that rule, and it will no longer check any of the remaining rules on the list. So next, a subnet can only be associated with one network access control list at a time. You can't have multiple network access control lists applied to the same subnet. A network access control list allows or denies traffic from entering a subnet. Once inside the subnet, other AWS resources, i.e. EC2 instances, may have additional layers of security known as security groups. And that's what we're going to talk to next. So that's a very nice transition. So if we look here, as traffic comes in through the internet gateway, through the route table sends it this way, it hits the network access control list, it then gets evaluated and making sure that the type of port and protocol that it's being sent over is allowed by the network access control list. It then enters the subnet that's been set up, but before it gets to the EC2 instance, it also has to pass through what is called a security group. So as where the network access control list is allowing or preventing access on the subnet level, the security group allows or prevents access on the instance level. So let's click on security groups and talk a little bit more about those. And I'll click on security groups over here as well. So security groups are very similar to network access control lists in that they allow and deny traffic. However, there are some differences in that security groups are security for the instance level as opposed to the subnet level with network access control lists. In addition, the way allow deny rules work are different from access control lists. Security groups only support allow rules. So now if you remember, for network access control lists, we could have both allow and deny rules. However, if I go here and I click on edit and I want to add another rule, I cannot select allow or deny. I can only select allow. So I can only allow any one of these different types of data from entering an instance. Also, what's very important to understand is that security groups are stateful. So now if you remember, network access control lists are stateless. These are stateful. So this means that return traffic requests are allowed regardless of rules. So what does that mean? Let me go into detail about that. Here we have SSH, and that is allowed into this particular security group or through the security group to an instance. For outbound rules, let's say for outbound rules, I changed this and I had this as HTTP. So that means that I'm allowing inbound SSH traffic, but only outbound HTTP traffic. However, if inbound traffic is coming in through SSH and that requires a reply, which is via SSH protocol, even though I don't have an SSH allow rule for outbound, because it's stateful, it will allow the traffic to come in as SSH, but also leave as SSH, even though I don't have an SSH rule in the outbound rules of the security group. So the same thing if I were generating, let's say, HTTP request leaving the EC2 instance, so going through the security group, and HTTP data was coming back, and I don't have an HTTP inbound rule set up, it will still allow that inbound request to come back through, again, because security groups are stateful. But again, it only works for return requests. So I had to initiate the request first, and that had to be allowed through to allow that type of data and protocol to come back and be allowed through the security group. So also, unlike network access control lists where rules were evaluated from lowest to highest, and the second that it found a rule that met the criteria, it would execute the rule and then stop looking at the remaining rules. With security groups, all rules are evaluated before deciding to allow traffic. So it's going to evaluate all the various rules that you may have. So if you have 3, 4, 5 rules, then it will evaluate all of them first and then decide, hey, can I send these through or not send them through? So another note here, best practice is to only allow traffic that is required. Now, before I explain again what that means, you should also recall back to one of our first lessons in this course when I mentioned a principle that described exactly this. Can you remember what that is? It is the principle of least privilege. So I mentioned that earlier in the course, and I mention it now because it is something that is very important to understand and to always follow as we're designing architecture and administering applications in AWS. Okay, so once again, now that we have a full understanding of how the components of the VPC work and how data flows in and out of a VPC, let's just recap and review this diagram one more time. So if we have HTTP requests, some data that's coming in from a customer via HTTP protocol over the open internet, first it passes through the internet gateway, which must be attached to the VPC. It will then come into the route table. And the route table is going to then direct it to the appropriate instance depending on the IP address that it's looking for. But as it leads the route table, it then needs to go through a network access control list. So that would have to have HTTP protocol allow rule set up in it, into the subnet, and the subnet has to be associated with the network access control list and with the particular route table, then to the security group, and the security group has to have an allow rule for HTTP in it as well, and then it can finally get to the EC2 instance, do whatever it will with that particular traffic, and then send it back out through the security group, past the boundary of the subnet, through the network access control list, back into the route table. The route table will then send it to the internet gateway, and the internet gateway will send it back out to the open internet to the customer. So I hope this is all starting to make sense, because understanding the basic fundamentals of VPC networking and having a real solid understanding of how this all works will really serve you for the remainder of this course on the exam and for your career in AWS. So with that, we will conclude this lesson. Thank you for watching. You may now move on.